Okay. All right.
And then expanded on the return statement is the return statement of a function or method identifies the point within its body where a value will be returned. If a particular return type has been defined, the value returned by the statement must match the defined return type. So in this case, the defined return type is int. We must return some int value, whether that is a variable or an int literal. Failing to do so will result in an error, not all code pass return value. So if you do have a type that is not void right here, and you lack the return keyword, you will get the not all code pass return value error, which basically says, hey, you're miscoded. Return statement will terminate the function's process, and as a result, no code after a return statement will be read. Using a single return statement within any function or method is best practice. So you can write multiple returns. It's not something that the IDE is going to directly error you out on. It'll give you warnings, but it is best practice to have a singular return, and it gets a little bit more
so we can get the first
easier to understand in Lecture 4 when there are potential more than one return path. But there is a very simple fix to mitigating that, and we'll see all that in our demo. Static modifier. So you're noticing that right here where it's highlighted as math utils.
Okay, this right here. Static modifier.
So effectively this nebulous library of code that we have imported or written. When we have the static modifier, so what's highlighted at the top here, is used to declare a static member which belongs to the type or the class itself rather than a specified argument. So again, day 7 to 8 material, but when we're talking about the lack of static, that means we're creating an object. And when we're thinking about classes and objects, we can think about like an int or a string, where int and string are their own classes, they're their own types. We're declaring it simply by saying int x or string x. When we get to the point where we ourselves are writing classes, so we're going to see one in today's demo, this is a short one, and then more so in lecture 7 and 8, we're going to be creating a object or a variable off of that class. So if we take, I don't know, phone as the example of a class, and then we have all of like the different data points that a phone might have, like screen size, processor type, how fast the RAM is, stuff like that. When we go to actually make the phone object like int x, it would be phone and then whatever we wanted to identify our phone object is. But when we have a static modifier, we don't even have to really worry about that. We just need to know that it exists and it's written in a class and what that class is called. Access modifier, so highlighted up at the top left, the public. Access modifiers refer to whether or not a particular piece of code can be accessed from another part of your project. For the purpose of this course, it will primarily refer to whether or not it is accessible within another class. All class members have a particular access level by default that may vary, even if one has not been explicitly defined with an access modifier. So depending on your operating system and your IDE case, I believe that Windows machines default everything to public. That may not be true in C++, it might be private because it forces you to write public. But in other languages like C#, Windows would default everything being public, and Mac would be default everything being private. And again, going to depend on the language, your IDE, or operating system choice. Right here, we're talking about scope, so we're immediately looking at scope braces. In programming, scope refers to the part of a program where a particular name or identifier is considered valid. So the scope of sum is anything within these curly braces for the scope braces. Generally, when you have scope braces, it is scoped to the parent entity above it, so in this case, sum. And then right here, it might be a little hard to read with the error text on screen. So we have above the declaration of sum, basically what we've seen so far in the slides. And then at the bottom, we're assuming like we're in the main or something, and we're typing out code that's going to utilize eventually this method. We have sum equals 5, and it says the name sum does not exist in the current context. So we note that sum right here, that we're assuming is in the main, and sum in here, which is scoped to the sum method. These are two separate entities. So you may have heard me say early on, you can't name something the same thing. That's true if it's in the same scope. So in here, we wouldn't be able to have another thing named lower as sum. The reason we get the error out here is it treats this scope as basically a new section for like fresh creation or fresh variables. And because they're in two different scopes, they can be named the same. But the error here is we just haven't created. And right here, we have an example of a class, so class person. So we start with the keyword and then an identifier. And then we have scope braces for the class. And we have some extra stuff that we could go in depth on it for what they actually are, but for all intents and purposes for lecture 3, we basically have a variable called name, string name. And then we have a get name method saying return name. And then this is all scoped inside of the person class. And you can also denote the lack of static in this method and the inclusion of public right here, opposed to right here. So this variable is only private, so it's only accessible via the person class, whatever file it's in. Right here, we have get name, this is public, so we'd be able to use get name in another file. So signature. Method signature is a unique piece of code that defines the purpose of the method. At minimum, it includes the method's return type, identifier, and parameter list, but may also contain an access modifier. So basically, a signature or head of a method is a declaration of the method itself, so the public static is and then the int number 1 in it versus parameters. So right here is, I think, probably the most complicated thing out of today's lecture. We're talking
static signature. Static signature.
about overloading. This is another way to break the rule of naming something the same thing with.
Okay, I have issues with overloading.
but this specifically refers to methods. So in C++, an overloaded method is a method that shares the same identifier but has a different parameter list, or a list of parameters in the return type for both. So on the very above, we have set against sum with two parameters, int number 1 and number 2. The goal of it is to get the sum of both numbers and return it. But an overloaded sum, it could be a different return type, it could be a different set of parameters. So the first one has 2, and an int return type, the second one has 3 parameters that are 3 ints and an int return type. Again, the goal is to get the sum of all the values provided, so in this case we have 3 values instead of 2. Basically, you can have quote-unquote infinite overloads as long as your parameter list and or your return type is different. So again, return type being the type to the left of the identifier.
Okay, so basically we're stopping at 26. We're going to create a page 2, with page 1, lecture 3, page 2. We'll come back to this. We're just stressing, brother. We're just stressing. Okay, that's the first 25 minutes done of lecture 3. I'm pretty sure we understand that, or at least we have a lot we need to practice. I'm going to close this up. I'm going to come over here, copy here. Okay. Just come here, start this up. Oh, shit. I've got to watch something, dude. I've got to watch something to cool down. I need to chill. I need to chill bad. Everything's attacking me at different angles, man. I just need to breathe. Everything's always attacking me from different angles. There's always something that's gonna mess with me. Someone's that's gotta target me. Someone that's gotta hold me down. Their toxic bullshit just makes me more toxic. God, dude. I want some peace. Don't you want peace? The only way through peace is hard work. The only way through peace is hard work. It takes about 30 minutes. That's the open window I get with the tutor. 30 minutes is more than enough to get past lab 4 tomorrow. We'll go through it, every bit of it. Okay, while we're waiting.
and the parameter list being anything inside the parentheses to the right of the other.
Okay.
Methods and keywords. So starting out, we have public. An access modifier keyword that, for the purpose of this course, will allow a member, variable, or method to be accessible within a class other than the one which is defined. And then private, an access
modifier. Accessible in class.
access modifier keyword that, for the purpose of this course, will prevent a member, variable, or method to be accessible within a class other than the one in which it is defined.
We'll come back to that. You're such a fucking coward, dude. I saw that shit.
Class members will be set to private by default if no access is specified. So we can look above. We have public static void show dialog with a string identified as message as the parameter. And all we're doing with this method is we're counting or console outputting the string message. And then we're calling another method show press any key.
Damn, dude. Shit. It's not what I wanted.
And then show press any key is a private method. It is static. It is void. Identified as press any key or show press any key. And what it does is we output to the console press any key to continue with a new line, and then we get a send.get, which basically will halt the program until we press any key, and then the program will continue. So continue keywords. We have void used as a return data type when a method or function does not require any data to be returned. So generally, when you're outputting stuff or you're not storing, you're going to store the value outside of the method or outside the class that the method originates. You can use void. And then we have public static void show dialog string message. We have a separator with two lines, the actual message, and then another separator with 2 lines. And then static, used to optionally denote whether or not a method should be used as part of an object instantiated from class. Kind of what I was talking about with the class phone example. If something is static, we only care about the class. We don't need to make an object. So if we think back to a previous slide where we have the math utils, scope operator, or scope resolution operator, and then sum, that's how we could use a static method from another class or another library.
Yo, my teammate's trash, bro. What the hell?
Return, used to denote the beginning of a return statement, precedes the value or reference being returned. So we have the statement right here that's in like light purple, and then the value or variable that we are returning.
return proceeds value or ref. Like we're not gonna win this. To tell you, bro, I don't know how the fuck he survived that.
And then using a single return statement within a function or method is best practice. Again, you can write multiple returns. It's just best practice. And if you put any code under a return, might be hard to see, but what it says for the error or the warning text is unreachable code detected. Because you have code under a return, and returns are the exit point of a method, anything under a return just will not be read or exit. This isn't an error in and of itself because it's not a red squiggle, it's a green squiggle, so it's just going to be a warning. It's not going to prevent you from compiling. It's just telling you, hey, nothing's going to be done with this line of code. So operators for methods, first is going to be the parentheses, which denotes the start and end of a method or function parameter list when used within the head or signature of a method declaration. They're also required when calling a function whether or not it has any parameters. So if we take a look at these two methods up here, the show dialog with a string message parameter, and then over here show press any key with no parameter list, note that we do still have to provide the parentheses when we make the method, and then when we also call the method, we need to provide.
Still don't have anything. There's no point to try, bro. Like, it's a waste of my time. I don't know why I queued for you motherfuckers just to waste it. But, you know what? Fuck it, who cares?
Provide the parentheses. Next is going to be the curly brackets or the scope braces used to identify the body of the method or function. So again, we have scope braces on both of these, the show dialog and the show press and key. That's going to be the body, the scope, or the block to the parent entity. So in this case, on the left, the parent entity being show dialog method. On the right, the parent entity being the show press and key method. And then just highlighting the parentheses. Right here, we have the show dialog with string message. We have a parameter actually in the parameter list. And then show press and keys with an empty set of parentheses because the declaration or the signature of show press and key does not have any parameters in its parameter list. And that is it for the slides. Before we take a small break, do we have any questions on anything before we jump into the demo? Go ahead and be back at 2. I'm going to get the recording paused and the project set up. All right. For those who saw me typing during the break, I just put a bunch of comments. The only thing that I actually added was the include of string. So you're going to see a bunch of notes that we've seen before, and then me organizing some stuff just for how the demo is going to go. We're going to do a little bit of a recap of everything. Basically going to be doing that moving forward and having a recap of as much as possible in the demo projects. So we're going to be starting with types.
We'll come back to the live demo for lecture 3 and finish the what are you guys doing, push up, bro?
So we have our native types. Keep in mind that some have an unsigned variant. Going through and declaring a bunch of different variables.
Bro, I don't know where to start. Oh my god, bro. Just like I'm too behind for this. Like why you gotta play this? What do you what do you just guide me here, you fuck? Oh my god, dude. Everybody likes to play these goddamn games. I hate people who playing these games. Just tell me the answers, bro. Just be straight. I swear, everybody's always got to play games, bro. Even Christians, man. Even Christians play games. They're the worst at it, too. It's disgusting. Jesus Christ.